Alright, so for the Unix part, again, most of the contents are not examinable, right? Except the last part. Last part is related to some topic we will study later. So the last part, actually, the last part is quite important in terms of security. Okay, so again, we will look at some programs that can allow us to maybe manipulate objects, change permissions, and so on in Unix and the Linux environment.
So can we also do it on Windows?
Sorry?
Can we also change the permission on Windows?
With what?
Windows.
Windows.
Yes. Can we also change the permission in the Windows environment?
In the you mean the
yes.
graphical user interface?
Yes.
Yeah, of course you can do that. But that's for non-computer science graduate, right? So they don't know how to write program, so they can only do it in Windows. But as a computer science graduate, you should be able to do it using program, right? So, yeah. Okay. So here are some again. For Unix, of course, you can also use command to change permission, but here we also see some programs that can change permission. For example, in some situation, you may need to write a program, which actually inside program, you need to do some like assignment of permission and so on. So the particular problem, I said, that is related to the later topic is this one. It's CSCI, right? I will talk about this later. Okay, so we will look at some programs that can like manipulate or handle the objects in the Unix and the Linux environments. Right, so we will also look at some example code. For example, this one is to, you can of course remove the file using the remove command. Right, you can remove the file using rm. Right, so if you want to remove a folder, probably you need to use rm-r. That means you recursively remove all the content. Otherwise, you will get an error message. So, but instead of using the command, so you can also use a program to remove the object, right? So when you remove the object, actually we don't care about permission, but when you create an object or create a folder, we need to look at the permission. So the permission can be set here. So we use this multi to set the permission string. So this is here is another example to like move to. So in the previous one, we said we can remove object, we can rename or move object. So rename is the same as move. So if you want, if you change the name, that means it's the same as you move move this object to the same directory but with a different name. Okay, so this is how you do the move or rename. To create, now you can assign the permission, right? So this is the same permission we started in the previous lecture. So 0, 2, 2, 0. So first 0, so first position you can ignore it at this moment because this is related to the so-called set UID, set GID, and so on. The remaining 3 are the permission list for the 3 groups: owner group, and then this is the owner, this is the group, this is the others. Right? So remember, we can use a number from 0 to 7 to represent the permission. 2 here means the owner can write. 4 means read, 2 means write, 1 means execute. If you have 2, that means that the owner can write. And the others cannot do anything because it's 0. Right? So you can assign permission to this particular file. Right? So in this case, but when you create a file or folder, then when you assign permission, actually this may not be the final permission assigned to the file or folder. Because in Unix, actually there is a so-called umask. So umask is the default permission that will be assigned when you create some file or folder. And you can change your umask in Unix. Right? So the umask basically is something default permission you will assign to the object or subject. And then if say you assign a permission which is lower than the umask, then the permission will be assigned. But if you assign a permission higher than the default permission, then in this case, the higher permission will not be allowed, only the lower one will be allowed. Okay, so you compare the permission you want to assign with the default one. You pick the lower one, because again, this is related to a default deny. So we pick the lower one when you have like a conflict between the default one and the one you want to assign. And the umask actually is in the opposite. So here is a bit maybe tricky. So umask is the opposite. 0 means you can do anything. 7 means you can do nothing. Okay. Anyway, so this is just different from the original one. You can also change permission, right? Of course, you can use this command, same command, in the same like a utility function you can use in the Unix, right? So you can change the command, you can change the permission by assign read, write, execute to other users. However, so the permission can only be changed by the owner or the administrator, the root user of the system, right? So you can also change the owner of the file. So these are the two commands to change the permission and to change the owner. So here is one example. So basically now you change the permission to 644. 6 means the owner can read and write. 4 means the others can read. Group can read. 4 means the last 4 means others can read. So the same as what we studied before. And the 0 here you just ignore. Later I will explain this 0. This 0 is for some special permission. Alright? So the remaining 3 are the normal permissions. Okay. Right, so this is basically, instead of using the numbers, if you can memorize the numbers, then you can use the numbers. Otherwise, you can also use these certain macros. These are the constant. These are the constant, right? So these are the constant. Basically, you allow remember, actually, if you want to assign permission, you can do an OR operation, right? So here, basically, you assign the read permission to the owner, write permission to the owner, read permission to the group, read permission to others. Right, so this is basically the same. It will have the same effect as this one. So instead of memorizing numbers, you can define some constant and then use these constants. So the constants actually are listed here. So you can like give the read, write, execute to the owner, right? So you can give read to the owner, write to the owner, execute to the owner, and so on. You can. These are the constants or the macros corresponding to these integers. Right. So you can also query the object. For example, like whether someone can read this object or not, because ACL determines who can do what to this object. So by querying the ACL, you can know, for example, whether Bob can read this file or not. Right. So the information actually can be found in this state structure. So the state structure actually contains a lot of content. For example, the file size, the owner of the file, the group owner of the file, permission string. So this is the permission string we just looked at, right? So basically, in this structure, it contains this one. This one is where we do the permission assignment, right? But you can also find like other information. For example, the owner's user ID, the file's group ID, and so on, and the file size, and so on. Right. So this is basically the program to find out who's the owner, the size, and the owner. So you can find the size here, and you can find the owner here. So basically, this is just a structure. So all the parameters inside the structure can be accessed. So we don't have a private parameter in the structure. Okay, so as I said, the permissions are stored in this particular element inside the structure. Right. You can check permission. For example, here you get this permission list, and you check. For example, you check this permission. Permission here means whether the owner can read or not. So this is again like a macro, right? So this is like a macro. You do an AND operation. If it returns 1, that means this macro is true. That means the owner can read. If it returns false, that means the owner cannot read, right? So this is just another example. So there are some other macros you can use, for example, to check whether this object is a file or a directory, or whether this is a link. Okay. And then here is a program to check the file format. So you can again use this file format to see whether this is like a directory, a folder or not. Okay. Alright, so we come to the last point. Actually, the last point is important because this is related to some topic we will study, like the buffer overflow topic we will study. So, in general, you will see read, write, execute in the permission string. But sometimes you can see a special symbol S. So S can appear here, S can also appear here. Alright, so this S actually is controlled by the first number. We have 4 numbers. The second to the fourth, they are for the owner group others. But the first number actually is for special permission. Right? So if you see a S, actually that means the first number is not 0. It's some other value. Then you will see a S inside the permission string. Right? So in this case, if the S appears here in the group, this is owner, group, and others. If S appears here, it's not a really big problem. But if S appears in the owner part, then this can be a problem. If we don't treat, handle this permission carefully. Right. So if S is in the group position, that means basically the files in the directory are forced to be the same group. So you cannot have files from different groups within inside the same directory. All right. You can also have a T. T means that the owner cannot be, the file can only be removed by the owner. But these are not major issues. The major issue is if S appears in the owner part. So in this case, we have the so-called set UID or set TID. So what does it mean? It means anyone who can execute the file will have the permission of the owner. Right? So basically in one sentence, set UID means anyone who executes the file will execute the program will have the permission of the owner of the program. For example, you create a program. You put the program in the Unix machine. You own the program. And now you allow other people to execute the program. So if the set UID is not on, this S is not on, someone executes this program, then the program, you create a process. The process, basically, you create a process based on the program. So in this case, the process has the same permission as you. If the S is not there, you run a process. For example, I create a program. I put the program in the Unix machine. Now I say I allow anyone to execute this program. If the S is not there, when you execute the program, say if you are allowed to execute, I put like a X for all the users. Then if you run this program, you have your own permission. Say you may not be able to access another file because you don't have permission. However, if the S is there, then when you run the program, the process, the created process, the program does not have. Basically, the created process will use my permission instead of your original permission. So in this case, suppose I'm a root user, you are a normal user, so I can modify the shadow file, but you cannot read the shadow file. So now I have a program. Now I assign execute right to you, to all of you. That means you can execute this program. However, so if I have this S, this flag on, set UID on, then when you execute the program, also you are original normal user, but because this S is on, when you run the program, you will get my permission. Then you will have the root access. So this will cause problem because if later we will see in the buffer overflow, essentially when you run a program, so you may run some additional code on top of the original program. So in this case, say if the original program is owned by the root user, and now you run this program, now you get the root user's permission, and you run some additional program, malicious program, then you can do anything to the computer system. So that's the reason why this set UID must be very careful. So if you use the set UID, you put this set UID, this flag on. That means you grant your permission to anyone who can run this program. So the person who runs this program will have your permission, the owner's permission, instead of the default permission of the touch user. So that's why this set UID actually is, you must be careful when you use this option, right? So this is just some explanation why you need to be careful, because if say the program is owned by the root user and you have this set UID, then anyone who are allowed to run the program will have the root user permission, right? So in this case, this user may misuse this program to do some malicious activity. So when we look at this again, when we look at buffer overflow. So in buffer overflow, actually, when the buffer overflow occurs, the user may run some malicious code on top of the original program. In this case, the malicious code will have the permission of the root user, the owner of this program. Okay, so that's how to do the